Thank you. I'm going to set this out as a few questions. So, what are the stakes? What do we risk? How big is the problem? Secondly, what do we have to do? So, what should our reaction be? What does the response look like? Of course, I'll be arguing the stakes are very big and the response has to be very big also, but I want to try to be specific about what's involved in the response. What are we actually doing as a world in relation to what I will have just described as the necessary magnitude of the response? Nowhere near enough, of course, will be the answer, but again, the specifics matter. Fourth question, what are the obstacles? Why aren't we going fast enough? And of course, that's a fundamental preliminary to the last question, is what can you do? What can we do? So those are the 5 questions that I'll try to grapple with. And basically the conclusion that the risks are enormous, but the alternative path, the different ways of doing things, is deeply attractive. So that the problem is basically political will, and you have to ask yourself, how do you create, how do you foster political will? And that's what example, pressure, greening-hearting is all about, as I understand it. So let's first try to understand the stakes. You'll have to excuse me a few numbers and a little bit of mental arithmetic, but it won't be mental arithmetic that's beyond the capacity of the kids who use this hall, obviously, fairly frequently. So it's basic arithmetic, but the numbers really do matter. We're currently, in terms of concentrations of greenhouse gases in the atmosphere, somewhere around 440, 445 parts per million of CO2 equivalent. Most of that's CO2, most of it's carbon dioxide. But there's other greenhouse gases as well. We're adding around 2.5 parts per million a year to that 445 or so. And that 2.5 parts per million a year is rising. Over a century, it will probably, if we don't do very much, it'd probably average around 3 parts per million a year. So over a century, we'd probably add about 300 parts per million CO2 equivalent to the 440, 445 we are now. We'd probably be under not doing very much, under the assumption we don't do very much. We'd probably be around 750 parts per million around the end of the century. Now, that would give us a something like a 50-50 probability of a temperature increase relative to the middle of the 19th century, which is the usual benchmark. 50-50 probability of a temperature increase about 5 degrees centigrade. Now, we haven't been at 5 degrees centigrade as a planet above the middle of the 19th century for about 30 million years. We've been around as Homo sapiens maybe 250,000. But basically our civilization dates from the end of the last ice age in terms of settled agriculture. Because since the warming after the end of the last ice age, 10, 11, 12,000 years ago, over that period after the warming took place, we've essentially had a very stable world temperature, plus or minus 1 degree. And that's allowed us to cultivate the grasses so that grass becomes barley and wheat and rice and so on. If you sow seeds, then you have to stick around whilst those seeds grow, and indeed you have to protect them. So that means settled agriculture, villages and so on. And if you have seeds that you've grown, you can store. So you've got settlement, you've got storage, and you've got surplus. And they were the bedrock, as it were, bedrock from agriculture of our civilizations. Allows you to have universities, pay professors to write books and that sort of thing. So basically our civilization has come in a very narrow band, plus or minus 1 degree centigrade, and we're already at the edge of that band. And we're starting to move outside the band between which our civilizations grew. 5 degrees centigrade, as they haven't seen for 30 million years. 3 degrees centigrade, we haven't seen for 3 million years. We don't know exactly what a 3 degree, 5 degree world will look like, but we can be pretty confident it's radically different from where we find ourselves. 5 degrees centigrade less, we have experienced quite recently as a world, last ice age, 12,000 or so years ago. And the effect on sea level, for example, of that reduction. So warming raises sea level, cooling lowers sea level. You could walk from Paris to Dublin, no English Channel, no Irish Sea. You walked from Siberia to Alaska. And of course, there were a lot of, not many people around, but this is 10, 12,000 years ago. Human beings have been around for 250,000 or so. The point that I'm making here is this is a radical transformation in where you can be. It transforms where you can live. When temperatures were 5 degrees or centigrade or so below, nobody lived north of Watford, at least in the northern hemisphere. You can't do that in the United States, but on the whole, Watford gets a grin, but you have to be in a very specific locality for Watford to make people smile. But the point here is these kinds of temperatures move people massively. It probably would involve hundreds of millions of people moving at 3, 4, 5 degrees centigrade, and moving people would very likely involve severe and extended conflict. If we know anything from the history of the last few centuries, movement of people involves conflict, and this would be movement of people on a massive scale, hundreds of millions, possibly billions of people. Those are the kinds of stakes that we're playing for. We can't tell exactly where these changes will take place, but we can be very confident that very large changes would take place if we let that happen. Probably much at 3, 4, 5 degrees, much of southern Europe would look like the Sahara Desert. Indeed, what you see is the deserts around the equator expanding. You're already seeing northern Nigeria under great pressure, a very densely populated country, a couple 100 million people. People in northern Nigeria are put under that kind of pressure. They start to move south. You have serious conflict. The conflict in Darfur is in part associated with the change of the climate. You're seeing that conflict in a significant but very small way now, because what we've seen so far is around 0.8 degrees centigrade increase. We're talking about 3, 4, 5 during this century. As I said, on business as usual, excuse me, quite likely 5 over this century. So we're talking about incredibly fast, very big change occurring in the lifetime of the children who paint on these walls here. This isn't some abstract future generation. These are people we can look in the eye now. So we are playing as a world with their future and with and risk creating a world of great conflict arising from that radical movement of people. So those are the stakes that we play for. We're already in territory which is on the borderline of what we experience in the civilizations as we know it, on the borderline of that. As we move out of that, we're into territory which is more and more uncharted. 3 degrees, as I say, we haven't seen for 3 million years on the planet. So this is risk on a colossal scale. We can't predict exactly what will happen. There are lots of uncertainties here. But what it does seem, as a basic scrutiny of the science, that those risks are immense. Essentially, we're playing Russian roulette with the future of the planet. At this point, sometimes, let me do it tonight. How many people here know what Russian roulette is? Yeah, good. And how many people here have ever played Russian roulette? Well, you're wise, but that's what we're doing here. We can't tell exactly what will happen, but we can tell that the risks look immense. And those who would tell you that there's nothing to worry about have to say something much more than that. They have to say that notwithstanding 200 years of serious science, they know that the risks are small. Now that would just be to fly in the face of the evidence. It would be irrational, anti-science, and just very odd. Yet you do find some people who make those very odd statements, but they won't often go as far as they really have to go to make their case. If you challenge them and say, please explain to me in the light of 200 years of serious science why you know the risks are small. What is it that you've understood that the National Academy of Sciences of United States, of the UK, of France, of Australia, or China, wherever you look, what is it that you've discovered that these people have missed? Because you're telling us you know the risks are small. Of course, they've discovered nothing. But nevertheless, you see a very well-funded and very well-orchestrated attack on the science, with quite close similarities, indeed, some of the same people who attacked the link between cigarette smoking, between tobacco and health. And those of you who'd like to see the story of it, there's a very good book by Naomi Oreskes called Merchants of Doubt, and describing in various ways acid rain, smoking, climate change, how those with very powerful vested interests have attacked and tried to create doubt about science. But in this case, of course, the doubt's not enough. You have to say something much stronger than that. You have to say that you know the risks are small. So I don't want to go, I'm more than happy to answer questions on the science. I happen to have a mathematics degree of 40 years or so ago. That doesn't make me a scientist, or it does make me more of a scientist than most of the people who attack the science. But if you want to look at the science, go to the Royal Society. I was with the President of the Royal Society this afternoon, who's having a tedious correspondence with Nigel Lawson. I was 2 weeks ago, I was with the government chief scientific advisor, having a tedious correspondence with Nigel Lawson. The chief scientific advisor's correspondence with the good Lord Nigel is in the public domain, because it had freedom of information requests about it. So you can get that if you want, and if you can't find it, I can give you the references. But page after page after page, from the chief scientist, the president of the Royal Society, of all the mistakes that they make. But they just keep on coming back because they're not interested in rational argument. They're interested in undermining something. But basically, if you want to learn more about the science, go to the Royal Society, go to the American National Academy of Sciences, go to the Chinese Academy of Sciences, go to the Australian and the French. Anyone you look at, there's not one National Academy of Sciences that will say anything different, because the evidence is so powerful. It's 200 years of science, starting with Fourier in the 1820s, who worked out from a heat balance equation that the world was warmer than it should have been. So he concluded, he's a great man, that 1820s, something was trapping. By the middle of the century, the middle of the 19th century, Tyndall, an Irish scientist, worked out experimentally what were the gases that were doing it. By the end of the 19th century, Arrhenius, a famous Swedish chemist, started to do calculations on what temperature increase would come as a result of the different assumptions about rising greenhouse gases. He got quite close, actually, even then, to the numbers that came later. In the 1930s, they worked out how it was happening. Essentially, the oscillation of the greenhouse gas molecules interferes with the infrared energy which is reflected back off the Earth. Ultraviolet comes in, reflected back as infrared, and it's the greenhouse gas molecules that, and this is the definition of what is a greenhouse gas, that oscillate at the frequency that interferes with the infrared. So what you got is the basic physics of this worked out, starting from the 1820s, really thoroughly worked out over 100 years, and then what you've got is just an overwhelming sequence of data that's come in support of this theory. This is no correlation looking for a theory. This is good basic science that's overwhelmingly supported by the evidence that comes in. But like many parts of science, it has uncertainty. It's about risk, and this is about managing risk. So those are the stakes that we're playing for here. They are immense, and they should worry us. We should be worried. But that's not enough. You can't simply speak about the scale of the problem. What do you have to do? Well, up to 2 degrees, another degree is already quite worrying, but in terms of looking at various kinds of tipping points, the scientists have argued that beyond 2 degrees is dangerous climate change. We don't know, again, there's lots of uncertainty here, exactly what will happen. But if the permafrost starts to go and starts to release methane, and of course soil starts to get washed away and you lose the carbon from the soil, you could get a very powerful feedback effect. It looks as if it's possible that a number of forests would die back as you went much beyond 2 or 3 degrees. Again, an accelerating feedback mechanism that gives you complicated dynamics that feed off each other and take you further and further down the track. Those are the kinds of dynamic feedbacks that you can get that destabilize the whole story, which we don't yet know very much about, but we know enough about them to think that they're rather dangerous. And that's why people talk about 2 degrees centigrade. You get tipping points, the frequency and risk of tipping points when you go beyond that and get into an unstable dynamic story where things feed on each other and it gets worse and worse, is the reason why people point to 2 degrees centigrade as a reasonable goal above which we shouldn't go. Now, if you are to give yourself a 50-50 chance of 2 degrees, you have to take the 50 billion tons of carbon dioxide equivalent that we currently emit as a world, 50 billion tons. You have to take that down to about 20 over the next 40 years to give yourself a 50-50 chance of holding to 2 degrees. It'd be nice to have a better than 50-50 chance of holding to 2 degrees, but even if you're modest in that sense, you have to bring that 50 down to about 20 over 40 years. So the total emissions that we see in the world have to be divided by something like 2.5 to get 50 down to 20. If we manage our economies well, over 40 years they might grow by a factor of 3 or so. I mean, not if we manage them badly and not if we make a big mess of the climate, but that means that if the economy grows by 3 and you're going to drop absolutely from 50 down to 20, you've got to divide emissions per unit of output. There's nothing beyond multiplication and division in this talk. You've got to divide emissions per unit of output by something like 7 or 8. 3, factor of 3 because output's going up by 3, factor of 2.5 because you've got to cut the current 50 down to 20. You've got to divide emissions per unit of output by 7 or 8. Now, there's some parts of the economy where it's not going to be very easy to do that. Yeah? So the answer is that where you can, you've got to go to 0. Essentially, in 40 years, we've got to have the power sector at 0 emissions. Maybe even with biofuels with carbon capture and storage, you could imagine it actually being negative. And that's possible. But that's the scale of the transformation that we have to make. There's one hope of getting major negative emissions, and that is to let the degraded forests regenerate. If we managed as a world to take the very big fraction of our forests which have become degraded, and if we protect them then and leave them, they will grow. So the regeneration of degraded forest seems to me to the one part of a geoengineering story that could actually give you real value. So that is a very important, it won't do it by itself. You're going to have to cut emissions per unit of output radically too. But of all the schemes that could give us a little bit of breathing space, allow us to really give us an opportunity to improve the chances of holding 2 degrees, that's the one I think that we can think about and discuss. But firing muck up into the atmosphere doesn't take out the CO2. It doesn't stop you poisoning the oceans. Yeah? It stops some of the energy coming in, but it still leaves you with the basic problems. And you'd have to keep on doing it. You couldn't just do it, do it every year. So the messing about with the planet as a whole is extremely dangerous to try and get us out of this problem. But regenerating forests could be a big part of the story. But basically what I've described is an energy industrial revolution. Now, as soon as you start, this is the what do we have to do? We have to have an energy industrial revolution. About half of what we have to do, we could probably do through energy efficiency. That's the biggest kicker here, and hugely valuable, obviously, less pressure on resources in its own right. We probably, we're going to have a lot of renewables, new ways of doing things. Many people, myself included, think nuclear will play a role. Carbon capture and storage will also be important. But the dimensions of this problem are so big that we would be mistaken to rule out any technologies at this stage. If we really wanted to, energy efficiency and renewables could do it. But it's probably, over the period that we've got, going to be quite costly, and I think you're likely to need nuclear and carbon capture and storage as well. But we have to investigate all these things. But the good things about energy industrial revolutions, or the good things about industrial revolutions or waves of technological change, is that they're very exciting periods in the life of the world. If you look back to the first industrial revolution, the second part of the 18th century, if you look at steam and railways in the middle of the 19th century, you know, if you look at electricity and steel towards the last part of the 19th century, if you look at the motor car and mass production, the early part of the 20th century, if you look at information communications technology, ICT now, and we're nowhere near the end of that one. I mean, we may only be near the beginning of that one. But what you see in all these great waves of technological change, you see 2 or 3 decades of innovation, investment, growth, discovery. These are very exciting periods in the story of technology and investment. They are actually growth periods. But of course, growth in this case through discovering and implementing these new and much cleaner technologies, these new, much more energy efficient technologies. And with all this discovery, with this investment, with this growth story, you get something which is more energy secure, it's cleaner, it's quieter, it's safer, and it's more biodiverse. And you get this for probably investment of 1 or 2% of GDP. It is a fantastic return for 1 or 2% of GDP. So what you've got, as it were, is a picture of where we need to go, where we understand the scale of what we have to do. We can see the technologies. We know that if we go down this path, we'll discover and innovate right the way through. We don't know exactly what will happen, but we can look at economic history, we can know how to start, and we can predict that the discovery is going to be very exciting. So that's the story of the alternative. So I've described the risks, I've described an alternative. We really can do this. It's up to us. It's a choice. There's only one choice, it seems to me, that makes sense. And it's a story which over these next 2 or 3 decades could generate enough growth in the economy, clean growth, that would allow us to tackle the other defining challenge of this century, which is overcoming world poverty. The 2 defining challenges of the century are overcoming world poverty and managing climate change. And we can see how we can do them both. And actually we can see that unless we do them both, we will do neither. If we fail on one, we fail on the other. If we fail to manage climate change, we create an environment that's so destructive that development, and there's been a lot of development over the last 30, 40, 50 years, would be reversed. We have a world with increasing poverty. If, on the other hand, we try to manage climate change in a way that puts obstacles in the battle to overcome world poverty, we'll not create the coalition that we need to manage climate change. If you fail on one, you fail on the other. And actually, I spent a lifetime working on economic development in Africa, India, China, different countries around the world. That's what I did before I got into climate change about 8 years ago, and that's what I still do. And it's, for me, the prime driver of this story is overcoming world poverty. But then you quickly realize that unless you manage climate change, you won't. And then you look at climate change and say that is a deeply important problem in its own right, even if you weren't interested in world poverty. I mean, shame on you if you're not, but even if you weren't, you'd see the centrality of climate change. So where are we going? Third question. I said that 50 billion tons CO2 equivalent a year was the current emissions. That's rising. And it's going to be a real challenge to get that down. We should really peak, if we're to give ourselves a reasonable chance of holding to 2 degrees, reasonable being 50-50, we should be peaking in the next 5 or 6 years. There really isn't yet any sign of that. If you look at the promises that people made in Copenhagen, Cancun, in Durban, in Doha, at the last UN Framework Convention on Climate Change meetings, if you look at those indications of promise is too strong, if you look at those indications of intent, they would take us to something over the next 20 years or so, something more like 55 or 60 billion tons of CO2 equivalent per year. In other words, the current intentions, even embodying the cuts that are being offered in those intentions, are taking us up, not down. And so are we going anywhere? Yes, we are. The world is starting to grapple with the problem. Are we going? So it's not true that nothing has happened. That's just completely false. If you look at China's 12th five-year plan, it's a real radical, started 2 years ago, it's a real radical change from the past. I'm in China 2 weeks from now. We're discussing with the next round of senior leaders how they're going to take that forward to the 13th, 14th five-year plans. But if it's wrong to say nothing is happening, if it's wrong to say people are not engaging, it's also wrong to say we're on the right track. We're nowhere near on the right track, and we have to accelerate as a world if we're to get anywhere close to holding to 2 degrees centigrade. Our current trajectory looks more like a 4 degree centigrade path than a 2. And as I said, we haven't been at 3 degrees centigrade for 3 million years. We as Homo sapiens, 250,000. We actually, in our current civilization, perhaps 12,000. So we are often, at the moment, even with the intentions of the UN Framework Convention on Climate Change meetings, we're off into uncharted, very dangerous territory. So where are we going? Not going very well. Is it true that nobody's doing anything? That's not true. And you've seen in the United States and Europe some public reaction and pushback, but actually emissions in the United States are falling for 2 reasons, well, for 3 reasons really. One is the substitution of gas for coal in electricity generation. The second is quite a lot of regulation on efficiency, particularly in cars. Now, the car standards, whilst they still spew out much more than we do, it's much less than it used to be, which is something. And of course, we've all seen slowly growing or falling economies. But emissions in the United States over the last 5 or 6 years have come down, notwithstanding the difficulty in US politics on this issue. You're not going to get any legislation through the US Congress, but the World Resource Institute, the Environment Protection Agency, are looking through what they can do through regulation without getting primary legislation in the United States. So there's some movement. Europe, we've seen hesitation and pushback. But if you look further out, if you look at China, if you look at India, if you look at Ethiopia or South Africa, Brazil, Indonesia, people are really grappling with this problem. But, and it's a major but, it is nowhere near fast enough. It can't happen without the developing world. 20 years ago, 2/3 of the emissions are in the rich world. 10 years from now, 2/3 of the emissions will be in the developing world. For the rather good reason that the developing world has grown. And who are we to say that shouldn't happen? And it's still the case, even if 2/3 of the emissions 10 years from now will be in the developing world, you've got more than 6 billion out of the 7 plus billion people in the world from developing countries. So emissions per capita still far lower in the developing world than they are in the rich world. But unless we find a way of combining overcoming poverty and managing climate change, unless we find a way of combining those things, you're not going to get the buy-in of the countries in the world that have 2/3 or will have 2/3 of the emissions 10 years from now. But for all the reasons I've described, we can do exactly that. We can be much more energy efficient. We can use much more solar and other renewables in the developing world. There's a great deal we can do, but it has to be a partnership between rich world and poor world if that's going to happen. What are the obstacles? Fourth question, so I'm going to have to move a bit more quickly. I can take that fairly rapidly. What are the obstacles? The biggest obstacle, in my view, is that people mistakenly see this as an artificial horse race between growth on the one hand and climate responsibility on the other. A rather innocent and charming young man said at the Tory party conference not so long ago that you don't manage or you don't beat climate change by putting the UK out of business. Well, George is a little bit confused about this subject, and we're doing our best to... I mean, David Cameron actually is very clear on this subject. But what you see is this attempt to turn it into one or the other, growth or climate responsibility. And the story I've told is that over the next 20 or 30 years, we can and should have both. Not growth forever, I mean, forever's a long time, but over this next 20 or 30 years, particularly growth in the developing world can be combined with climate responsibility. Over this last 5, 6 years, this depression, with interest rates on the floor, with massive unemployment, we should have been investing like mad in new technologies. Unemployed resources, close to zero interest rates. Surely that should have been the moment to grow ourselves out of a depression by investing in the growth story of the future. We can still do that, and we still should do that. But what you've got is governments around the world giving ambiguous signals. And the biggest obstacle to investment now in these areas is, on the whole, government-induced policy risk. If you're going to invest in a power station, well, if it's a nuclear, it might be £10 billion, £5–10 billion. If it's gas, you know, it might be $1 billion. If it's big renewables, similar kinds of money. You don't put that money as a major investor if you're clueless about where government policy is going to go. And what we've managed to create, particularly in Europe, but also to some extent in the United States, is deep ambiguity about where government is going. So, for me, getting clarity on policy is the most important thing to drive investment. This is the big obstacle to growth. Picturing this story quite falsely as a horse race between growth, poverty reduction on the one hand and climate responsibility on the other. And then, as you have that argument, creating uncertainty about where government policy is going. And that's a killer for investment. And you have a real paradox in this country with the big firms, very cash rich. I know not the small firms, but the big firms, very cash rich, waiting to invest, unemployed resources, interest rates on the floor, and you have this impediment to driving that investment. And it comes from lack of clarity. So the big problem is political will. The big problem is clarity. I had one of the greatest economists of modern times who taught me, a chap called Bob Solow, used to start his economics lectures to the undergraduates and say, in economics we need 3 things, he said: faith, hope and clarity. And the greatest of all these is clarity. And clarity in policy is absolutely fundamental. And it's the political will, the political dust that's kicked in the air is undermining that kind of investment. So it's political will. So we have to tell the story and tell it clearly, give the numbers, give the examples, and show that this story of climate responsibility, this new energy industrial revolution, cleaner, quieter, safer, more diverse, more energy secure. That's the kind of future that we can have for investment of 1 to 3% of the economy over and above what we'd otherwise have done. Surely, whilst you've got depressed economies, this is the right way forward. Even if you haven't, it's the right way forward. And that's what we have to be able to describe. That's what I tried to describe in the book and where I lay increasing emphasis. So what can you do? What can we do? I've said the biggest problem is political will. The biggest problem is, as a society, you can't blame all this on politicians. As a society, we haven't risen to this challenge with sufficient clarity of argument and sufficient strength of will. So the problem is creating the political will. If we create the political will, we can see what to do, and we'll discover like mad along the way. So the challenge is creating the political will. Well, you've got to have the arguments marshalled. That's the job of people like myself who live in universities and write books, do research to try to help marshal the arguments. But you're not going to get there just by marshalling the arguments in books and universities. You've got to have politicians who are capable of expressing that. Bill Clinton at the Denver Convention, which adopted Barack Obama, 5 years ago now, said the key, he said, for the United States is to show the power of the example, not the example of our power. We need clear arguments. We need them to be clearly understood and articulated by political leadership. We need examples of what can be done. And there is nothing like the power of the example. I was chief economist of the World Bank for nearly 4 years, and I used to talk to presidents and prime ministers and say, well, thank you, Professor Stern. Could you name one country where what you're suggesting has been done and has been successful? Well, the first time it happened to me, I flannelled a bit. The second time it happened to me, I had a load of examples in my pocket so that I could respond to those questions. And that's why the examples of what you do in Greening Harting, of what we do, you know, we all, I mean, our friend Andrew Shaxson here has just, he showed me the other day, has just installed a great wood chip burner. Well, he's fortunate to have a wood, and which you can cultivate sustainably. You know, we have ground source heat pumps. I should really change the rather old Prius that we've got outside for a much more modern and fuel-efficient one. But there are so many examples of what we can do, and Terina and Greening Harting are about those examples. It's those examples that will be really telling, that will show people that this energy industrial revolution that we talk about by looking at economic history, we talk about through our discussions of economic policy, that it's real. There's so many things that you can do, whether you're in agriculture, you know, whether you're in manufacturing, as a householder, whatever it is you do. There's so many things that you can do, and it's those examples that will help drive the political debate. So you need the research. That's the job of people like me. You need people who can articulate that and speak up, particularly politicians and journalists, media, and so on. But that has to be built on very powerful examples that people can touch and see and they know can work. If you see people saving energy through insulation and you see what you can do very cheaply, those are the kinds of examples that persuade people, that can get somewhere. So where I want to leave this, where I want to conclude, and I know Terina's got some real examples that she's going to show you rather than the abstract stuff that I'm offering. The power of the example is absolutely fundamental. That's the way in which you can change politics. Make the arguments, show what can be done, and this is a political argument that can be won. If we don't win it, then we have to look at the young kids who work in here and explain why we knew what the problems were, we knew what the risks were, and we didn't actually do anything. And none of us, I think, would want to be in that position. Thank you.